For thousands of years, when people dropped dead in the street during a plague, the survivors did something that seems unthinkable today. They kept living beside the bodies. They slept next to them. They prayed over them. Some even washed them by hand, believing that was how you honored the dead and helped their soul move on. In some cities, corpses stayed in homes, courtyards, and open carts for days before anyone came to collect them. Nobody understood the danger, not because they were careless, but because the real explanation was invisible, literally invisible. It would take thousands of years, dozens of catastrophic epidemics, and a handful of doctors who were mocked, ignored, or professionally destroyed for telling the truth before humanity finally understood what was happening every time a body was left unburied. This is the story of how we figured it out, and the answer is stranger, slower, and more recent than most people realize. Here's the question that took humanity thousands of years to answer. Why did people who handled the dead so often get sick and die themselves? Gravediggers, priests, family members washing a body for burial, executioners, battlefield medics collecting the fallen. Across cultures, continents, and centuries, this same pattern kept repeating. Something was clearly happening. But for almost all of human history, nobody could see what it was. There were no microscopes powerful enough, no germ theory, no concept that an entire invisible world of living organisms existed on our skin, in our blood, and in the air around us. So people did what humans always do when they face something they can't explain. They built a story to fill the gap. And for most of history, that story was completely wrong. Understanding how we moved from that wrong story to the right one isn't just a medical history lesson. It's a story about how hard it is to change your mind, even when the evidence is standing right in front of you, decomposing in plain sight. For most of recorded history, disease wasn't blamed on anything biological at all. The ancient Greeks and later most of medieval Europe believed in something called miasma, bad air. Rotting matter, they thought, released poisonous vapors into the atmosphere. Breathe that air and you got sick. Some physicians even believed the poison could travel for miles on the wind, carried from swamps, battlefields, and burial grounds into nearby towns. It wasn't a crazy idea for the time. Rotting bodies do smell terrible, and bad smells were consistently found near sickness, so the logic seemed to fit. Bad smell equals bad air equals disease. For over 1,000 years, this idea shaped how cities were built, how hospitals were designed, and how doctors treated their patients. The problem was, this theory was about to be tested on a scale nobody could have imagined. In 1347, a disease arrived in Europe that would kill somewhere between a third and half of the entire population in just a few years. The Black Death. Bodies piled up faster than anyone could bury them. Mass graves opened across cities. In some towns, so many people died so quickly that officials simply stopped keeping records. And the people whose job it was to deal with those bodies, the grave diggers, the plague doctors, the priests performing last rites, were dying at horrifying rates. The response makes sense once you understand miasma theory. Plague doctors wore those now famous beaked masks stuffed with dried flowers, herbs, and spices. They weren't trying to block germs. They believed they were filtering out poisoned air itself. Some cities burned massive bonfires day and night, hoping the smoke would purify the atmosphere. Others rang church bells constantly, believing the vibrations could break up the poisoned vapor drifting through the streets. Here's a twist within the twist. That beaked costume, built on a completely wrong idea, may have accidentally offered a small amount of real protection anyway, simply by creating a physical barrier of leather and cloth between the doctor and infected fleas or contaminated fluids. A wrong theory producing an accidental right result. Keep that pattern in mind because it's going to repeat throughout this story. But miasma theory couldn't explain everything, and careful observers noticed the cracks. Some people who breathed the exact same bad air stayed perfectly healthy for weeks, while others who simply touched an infected body dropped dead within days. Doctors wrote about this contradiction. They just didn't have the scientific framework to explain it. For the next several hundred years, that framework simply didn't exist. Quarantine practices spread across trading ports in Italy. Ships were held offshore for 40 days before anyone was allowed to disembark, which is actually where the word quarantine comes from. It worked remarkably well at slowing outbreaks, but nobody understood why. They assumed they were giving poisoned air time to dissipate, not realizing they were actually giving an infectious incubation period time to reveal itself. Then, in the 1800s, everything started to change. Not because of one dramatic discovery, but because of a series of doctors who paid close attention to patterns everyone else had learned to ignore. The first real breakthrough came from a Hungarian physician named Ignaz Semmelweis, working in a Vienna maternity hospital in the 1840s. He noticed something disturbing. Mothers giving birth in the ward staffed by doctors and medical students were dying of a fever at a much higher rate than mothers in the ward staffed by midwives, sometimes several times higher. He tested every explanation he could think of. Overcrowding, the position mothers gave birth in, even the root priests walked to deliver last rites. None of it explained the gap. Then he noticed the one real difference. The doctors were coming straight from performing autopsies on cadavers in the hospital's morgue, then walking upstairs to deliver babies, without washing their hands in between. Semmelweis had a radical idea. He believed the doctors were carrying invisible, cadaverous particles from the dead bodies directly into the birthing mothers, and that this was what was killing them. He ordered every doctor under his authority to scrub their hands in a chlorinated lime solution before touching any patient. Deaths from the fever dropped by more than 90% almost immediately. It was one of the most dramatic results in the history of medicine. You'd think this would have made him a hero overnight. Instead, the medical establishment rejected him, sometimes furiously. There was no visible germ, no accepted scientific mechanism, nothing that fit the world as respected doctors understood it. Being told that their own unwashed hands were killing patients felt, to many of them, like an insult rather than a discovery. Semmelweis was ridiculed by his colleagues, pushed out of his position, and eventually died in an asylum, still convinced he was right, and still not believed by the people who mattered most. He was right. He just didn't live to see it proven. The next piece of the puzzle came from a very different disease in a very different city. In 1854, London was in the grip of a violent cholera outbreak, and a physician named John Snow refused to accept the miasma explanation everyone around him trusted. Instead of blaming the air, he did something almost nobody had thought to try. He walked the streets of the Soho neighborhood and mapped every single cholera death, house by house, marking each one on a paper map of the district. The pattern that emerged pointed to one location, a single water pump on Broad Street. Case after case clustered around it, while a nearby workhouse and a local brewery, whose workers drank almost no water from that pump, had almost no cases at all. Snow convinced skeptical local officials to remove the pump's handle, making it impossible to draw water from it. Cholera cases in the area collapsed almost overnight. He hadn't seen a germ under a microscope, and most of London's medical establishment still didn't believe him. But he had proven, through pure observation and careful data, that something in contaminated water, not poisoned air, was spreading the disease. It later turned out that a nearby cesspit, leaking waste from cholera victims, had been seeping directly into the well beneath that pump. Two doctors, two completely different diseases, two independent discoveries, decades apart, both pointing toward the exact same conclusion. Something was being physically transmitted from person to person, not through the air people breathed, but through direct contact, contaminated water, and unwashed hands. Then finally came the discovery that tied every thread together. In the 1860s and 1870s, French chemist Louis Pasteur and German physician Robert Koch independently confirmed what Semmelweis and Snow had suspected but could never fully prove. Specific living microorganisms, bacteria, cause specific diseases. Koch went further, developing rigorous scientific methods still used today to prove that one particular germ caused one particular illness. His work would eventually identify the exact bacteria responsible for cholera, tuberculosis, and anthrax. Suddenly, decades of scattered evidence snapped into focus. The cadaverous particles Semmelweis had described weren't a vague, mystical poison. They were bacteria, transferred from a corpse to a living patient on unwashed hands. The contaminated water in Soho wasn't carrying bad air at all. It was carrying live cholera bacteria, multiplying in human waste. Dead bodies weren't dangerous because of some invisible vapor drifting off them. They were dangerous in specific situations because certain diseases, cholera among them, could leave behind living bacteria in bodily fluids, and those bacteria could survive just long enough outside the body to infect the next person who made contact. But here's the twist that surprises most people, including many doctors and disaster responders even today. Dead bodies are nowhere near as dangerous as popular belief still assumes. Modern public health research, including guidance from the World Health Organization and the Pan American Health Organization, developed after studying earthquakes, tsunamis, and other mass casualty disasters, has found that corpses rarely trigger epidemics on their own. Most people who die suddenly in accidents, disasters, or violence aren't carrying an active infectious disease at the moment of death. The organisms that do make a body genuinely risky, like cholera bacteria or certain hemorrhagic fever viruses, only pose a serious threat if the person was already infected before they died. And even then, Researchers have found the greater danger after a disaster usually comes from the living survivors, contaminated water supplies, and overcrowded shelters, not from the bodies themselves. In other words, the ancient fear was never entirely wrong. It was just aimed at the wrong target for most of human history. And now, even with the right target finally identified, we've learned the real risk is far smaller and far more specific than centuries of instinct ever assumed. So how did humans discover that dead bodies could spread disease? Not in one single moment, and not through one single genius. It happened in layers, across thousands of years. First, ancient observation noticed a real pattern that people near the dead often got sick, but explained it with an unprovable theory about poisoned air drifting through cities. Centuries later, individual doctors like Semmelweis and Snow used careful observation, rigorous data, and sheer stubbornness to prove that something physical, not atmospheric, was actually being transmitted. Finally, Pasteur and Koch identified exactly what that something was: living, microscopic organisms that could survive in blood, waste, and tissue after death, and pass directly into a new host. The truth was never that corpses release deadly poison into the air around them. It's that certain specific pathogens, present in a person at the time of death, can survive briefly outside the body and infect someone who makes direct contact, through blood, other fluids, or contaminated water. Most bodies carry no such risk at all. Only a relatively small number of specific diseases do, and modern science can now tell you almost exactly which ones. It took roughly 4,000 years, from the earliest urban plagues of the ancient world to a laboratory in Paris in the 1860s, for humanity to move from spirits and bad air to an accurate, evidence-based understanding of how disease actually travels from the dead to the living. And the doctors who got there first, like Semmelweis, often paid dearly for it. Being right too early in science has never been a guarantee of being believed. Sometimes it's the opposite. But that raises another mystery. If Pasteur and Koch proved that germs cause disease all the way back in the 1860s and 70s, why did it take doctors and hospitals another 50 years to consistently wash their hands and sterilize their instruments? The science was settled, proven, repeatable, undeniable. And yet the habits, the everyday routines inside hospitals, took generations longer to catch up with what everyone already knew was true. If you enjoy exploring the biggest questions about history, science, and our world, subscribe to this channel for more documentaries.